Howdy folks, welcome to 2-4 part 2. I told you yesterday that we were going to talk about identities and contradictions today. Those are your two vocab words that you wrote down yesterday. Identities. So when we're solving an equation, if you get an equation that is always true, that means it's called an identity and it has many solutions. On the other hand, a contradiction, if you're solving it and you get a false equation, that means it's a contradiction and it has no solutions. Now right away, one thing that happens whenever we learn about identities and contradictions is people start to think that every single equation they run into is going to be either an identity or a contradiction. That's not true. The majority of the equations you run into are going to be the ones just like you've been doing, where you solve, you get an answer, y equals 8 or whatever, and that's your solution. Identities and contradictions are kind of like, they're special cases. They pop up once in a while, but they pop up enough that you have to know what they are. That's why we have to learn about them. So don't think that from now on you're going to be writing identity and contradiction on every equation. That's not true. Just sometimes you'll see them, so you have to be able to recognize them. So I'm going to show you what it looks like when we have identities and contradictions. So they'll look just like any other equation. Okay, it doesn't have a big like flashing sign that says, hey, I'm an identity. Okay, it looks just like an equation that you run into. So you start to solve it just like any other equation. So here, remember the first thing we do is combine like terms. So I have 10 and plus 1, so that's going to be 11. So I have 11 minus 5x over here. Over here I got some more like terms, 7x and negative 12x. So 7x minus 12x, let's see, that's negative 5x plus 11. Now you might notice here that each side is very similar. Okay? And that's kind of your first clue. Now your second clue happens when you start to combine the variables. Okay, so I have x's on both sides, so I want to get them together. So I have a negative 5x, so I'm going to add 5x. Whatever I do to one side, I have to do to the other. Now, here's where the craziness occurs. Negative 5 plus 5, that's 0. That cancels just like we wanted it to. But then you'll notice here we have the same thing. Negative 5 plus 5, that's going to cancel. So I'm left with just this statement that says 11 equals 11. Alright, now when I end up with this, when my variables are gone and I have something like this, I have to ask if it's true or false. 11 equals 11. True. When it's true, that's when we have the identity. And that's when we say many solutions. Okay, so that's what our work would look like. We'd solve it just like any other equation, but our variables are going to cancel each other out. So then we have a statement. The statement is true, it's an identity, means many solutions. Let's look at another one. Again, looks just like any other equation, so let's start to solve it. I have 12x and x, so that's 13x. Over here I have 5x and 8x, so that's 13x minus 4. Okay, so then I need to get the variables together, so I need to move this 13x over with the other one. Now you'll notice again that 13 minus 13, that's 0, so I'm left with negative 3. 13 minus 13 here, that's 0, so our variables cancel. So then I have the statement negative 3 equals negative 4. That's not true. So when I have something that's not true, it's a contradiction. And it has no solution. So that's what contradictions are going to look like. Okay? So many solutions is where the statement at the end is true. Contradiction is where the statement at the end is not true. Okay? Then you'll also be seeing our favorite story problems on today's work. So, again, please write down this story problem. You will need it to look back at when you run into a story problem on your bookwork. So we have John and Sarah planting tulip bulbs. John has planted 60 bulbs and is planting at 44 bulbs per hour. Now we're going to write, let me just keep reading here. Sarah has planted 96 bulbs and is planting at a rate of 32 bulbs per hour. And how many hours will John and Sarah have planted the same number of bulbs? So in other words, when will John's amount equal Sarah's amount? So we need to write an equation for John and an equation for Sarah. So here's John. He starts at 60 already. And then in addition to that, he's planting at 44 per hour. Now, when you see the word per, it usually means multiplication. So 44 times, and we'll say H for hours. So however many hours John's been working, he plants 44 per hour. Now let's write an equation for Sarah. Well, Sarah started at 96. She's already ahead of John to start out with. But she's kind of a little bit slower, so she's planting at 32. And again, here's our word per. 32. And hour, so we'll use H. So there's the equation for Sarah. Now the question is, when will these be equal? So I need to solve this for H to tell me how many hours it will take before they've planted the same amount of bulbs. So I have variables on both sides. I need to get them together. So let's move this over. So then I have 60 plus 12H equals 96. Alright, now we're at the two-step equation, so I ask what's happening to my variable. Well, it's being times by 12 and added by 60. So the first thing I'm going to do is subtract 60. So let's do that. And I get 12H equals 36. And it's being times by 12, so I have to divide by 12. (36) divided by 12 is 3. So the answer to the first question, in how many hours will they have planted the same number of bulbs? Well, the answer to that one is 3 hours. Okay, now if you'll notice, there's another question here. It says, how many bulbs will that be? Well, in order to figure that out, we have to take our answer of 3 and plug it into either John's equation or Sarah's equation. It doesn't matter which one because they're equal. So let's choose John's. 60 plus 44 times 3. Well, let's see. 44 times 3, it's 40 times 3, which is 120, plus 12, that's 132. And 60 plus 132 is 182. Nope, not 182, 192. So that's the answer to our second question. In 3 hours, they both will have planted 192 bulbs. That's a lot of bulbs. So again, just to review real quick, I gotta write an equation for each thing that's going on in my story problem. There usually be 2 things going on, so I have to write an equation for each one. Then it will ask when will they be equal. So I set those 2 equations equal and I solve. Then I'll have to take my answer and plug it back into one of my original equations to answer the second question. And this is what my work would look like. Okay, this is what I'm looking for on your Friday quizzes. Alright, So identities and contradictions and some story problems. Alright, that's what you're going to run into on your work tomorrow. Remember, if you have any questions about this, make sure to make note of it and write it down. We'll see you tomorrow.